in this section, we're going to look at finding limits algebraically. So we might have a problem like this. Limit as x approaches 5 of x squared minus 9. So this is a very simple limit to take, because if we think about the graph of this, x squared minus 9, that's just a quadratic. It looks like this here if we flip over to a Desmos graph. And we're just looking for the limit as x approaches 5. So right here is where x is 5. You can see the y value here is 16. So we know that that limit there is just going to be 16 because you have a continuous function. So whenever you have a continuous function, your limit is super simple. All you're going to do here is plug the number in. So 5 squared minus 9 is going to equal 25 minus 9, which is 16. So there's your limit. Limit as x approaches 5 of x squared minus 9 is 16. We call this direct substitution, and for direct substitution, you just plug in the number. So if we look at number 2, we're going to plug in the number 1 over 2 plus 2 gives me 1/4. So the limit as x approaches 2 of 1 over x plus 2 equals 1/4. And so that just gives us the y value of the function at that point. Now, 3 is a little bit different, because look what happens when I plug in 2 for this one. I'm going to get 1 over 0. So if you'll recall what we were talking about with continuity, we know right here, because of this x minus 2 in the denominator, we're going to have a discontinuity at x equals 2. And so we have that discontinuity at x equals 2. It does not cancel with anything in the numerator. So what we have here is a vertical asymptote. And when we have a vertical asymptote, our limit is either going to go to infinity or negative infinity. In this particular case, you're wanting the limit from both sides. So what we need to say for this is just when we get a number over 0, we're going to say does not exist. Okay, so when you get a number over 0, 1 over 0, 5 over 0, a million over 0, you just say that that limit does not exist, because that is undefined. Okay, now, if we try direct substitution on this problem here, we've got the limit as x approaches 2 of 2 minus 2 over 2 squared minus 3 times 2 plus 2. So, plug that in like this. We're going to get 0 over 4 minus 6 plus 2, which is also 0. So I get 0 over 0. So when this happens, this is actually not a does not exist. What we call this here, 0 over 0, is our indeterminate. Our indeterminate form. So that indeterminate form is what it sounds like. If you're indeterminate, you cannot determine anything. So from 0 over 0, we get nothing. We don't know if the limit exists or does not exist. So if you plug in 2 and get 0 over 0, that is really like just seeing a big sign that says keep going. So let's look at what we can do for this problem. Okay, so if we get 0 over 0, it's quite possible that the reason we're getting 0 over 0 is because there's a hole in the graph. So the first thing we want to try, if it's a problem that looks like this, is we want to try to factor. So the numerator, of course, won't factor. So you just have x minus 2. But the denominator, we can factor it into x minus 2 times x minus 1. Well, the x minus 2's here can cancel. So that gives us the limit as x approaches 2 of 1 over x minus 1. And now that we have canceled, direct substitution will work. Notice I've kept the limit notation all along, but now I'm getting ready to plug the number in, so I'm going to drop my limit notation. So I've got 1 over 2 minus 1, which is just 1 over 1. So I get a limit of 1 for this problem. Okay, let's try some more. So here I've got the limit as x approaches 3, that's a negative 3, of x squared plus 5x plus 6 over x plus 3. Now, remember, we do need to check to see that we get the indeterminate form here. So if I plug in negative 3 squared plus 5 times negative 3 plus 6 over negative 3 plus 3, I'm going to get 9 minus 15 plus 6 over negative 3 plus 3 is 0. So 9 minus 15 would be negative 6 plus 6 would give us 0 over 0. So we check to get that indeterminate form. You don't necessarily have to write this down, but you do need to check for it every time. Because if you don't get indeterminate form, you're not going to be able to factor and simplify. So here, what I need to do now is I need to factor. So I've got the limit as x approaches negative 3 of x plus 2, x plus 3 over x plus 3. So those x plus 3's can cancel. So that's the limit as x approaches negative 3 of x plus 2. And if we just plug in our negative 3, we're going to get a limit of negative 1, for example 5. Okay. 6 is a little bit tricky because 6 is not factored, and we can't factor it as it's written. So what we've got to do for 6 is we've got to expand and then factor. However, I'm getting ahead of myself here. The first thing we really have to do is plug in to make sure we get the indeterminate form. So I've got negative 6 plus 3 squared minus 9 over negative 6 plus 6, and that's going to give me negative 3 squared minus 9 over 0, which is 0 over 0. So you get indeterminate form here. So even though it's a pain, we're going to hold on to that limit notation. X plus 3 squared is x squared plus 6x plus 9 minus 9 over x plus 6. So these 9's right here can cancel. And once they do, that gives us x squared plus 6x over x plus 6. In that numerator, I could factor out an x. So I'm going to say the limit as x approaches negative 6 of x times x plus 6 over x plus 6. And so here, the x plus 6 is canceled. You just have the limit as x approaches negative 6 of x. So you just plug in negative 6 for that x, and you get negative 6 as your answer. Okay. For 7, at this point, usually what's going to happen is you're going to do this limit as x approaches 2 of, let's see, x minus 3 times x minus 1 over x plus 3. Now, kids usually do this. This is their first step they do. And whenever you see this, it's not going to work because it doesn't simplify. So you must be thinking there's some other trick, there's something else I can do. There is not. The problem here is that we forgot to check for indeterminate form first, because we should have plugged in that 2 before we began to factor. So if we plug in that 2, we get 2 squared minus 2 times 2 plus 3 over 2 plus 3. So we get 4 minus 4 plus 3 over 5, and that gives us 3/5. So this was actually a direct substitution problem. One of the most missed problems I usually have on the test is a problem like this, because everybody's trying to factor it and getting it to cancel, and they forgot to try direct substitution. So you're supposed to try direct substitution before you try anything else.